Okay, we're back. We're still on this same PowerPoint slide, the do's and don'ts of dimensioning. Okay, we're on the lower row in D. And if you notice there in the front view or the left side view, whichever you want to call it, they got 3 individual views or dimensions there. All you need in that is 2 dimensions, that 46. Actually, you probably need to put a diameter symbol in front of the 46. It would be nice. And that diameter 20. That's all the dimensions you need for that drawing. So those 3 little individual dimensions you can leave out. In the middle there, E, you have some fillets or radiuses on the corners there. They're all the same thing. So you can leave 3 of those out and just make one note there. It says 4 times radius 50. 0.50 rather. And in F, let's see what they got there. Well, width, use one note. Okay, this is the deal. If you look at the depth, on the right hand side they have a line slashed through it. And if you look at the diameter in the front view of that circle, you notice they're the same thing. So you don't need that depth of 1. You can leave that one out. Okay? Okay. And then they put a note there that says 0.50 diameter to that one hole on the right. You already got a note up above. It says 2 of them, so you don't need to put another one. So we're continuing on. G in the upper one, you don't need the depth or height, or I guess in this case it'd be the height dimension, nor the width dimension, because you have a radius of 88. That's going to give you your height, and 0.174 is going to give you your from location. You're from the left to the center of the hole, and then you add 0.88. You got the overall dimension. So you don't need those 2. In the middle, H, they put a diameter 1.75 in the left view there, so you don't need the dimension inside the circle. What is that? I? Yeah, I guess that's I. Thread diameter preferred in the note. You'd rather have a note up above there, M12 times 1.25. Leave that dimension off those threads. That's a thread symbol, by the way, for screws and whatnot. J, arc center is self-locating. So that radius there, the R12, is basically, it locates itself. It's 12 from the right, 12 down from the top. So you don't need those other 2 dimensions. Omit either 20 or 22 dimension. Okay. So that 22 on the left, you can leave that out, or you can leave the 20 on the right out. It doesn't matter. Either one. Just leave one of them out. Okay. And then, what is that? L? That center dimension there in the top view, it's not needed, because your radius of R12 and the radius of R20 is going to locate what that size of that line is in the middle. Angles. Angles are dimensioned by specifying the angle in degrees and a linear dimension. So in A, you have a distance and an angle. That's pretty much how we do polar dimensioning. Remember polar dimensioning? As long as you know one distance and one angle, you can draw that line. Or if you know two distances, you can lay out the two distances like in B. C, you got 15 degrees. Over on the right hand side, you have an example of civil engineering project. That thing on the left there is concrete. That's the section symbol for concrete. And on the right there, that's the section symbols for earth and earthwork. And then you have above there, you have C and D and E and F. Those are ways of putting dimensions on a angle. Dimensioning arcs, fillets, and rounds. So there's the examples of how to do that. There's different ways of doing it, so I'm going to let you look at it. A, you put a center mark, you got a radius there. B is center mark and radius. C, you don't put a center mark, it's getting smaller. So as you get smaller, you kind of leave out the center mark. And that's, that's a one way of doing that radius. Another way is D. And then you have an inside fillet E there. And sometimes you have to stagger your radius to get your dimension in there, so that's F. Most of the time you're going to put a note in there saying fillets R6 and rounds R3 unless otherwise specified. Remember, fillets and rounds are two different things, even though we use the fillet command to do both of them. Okay? Or all casting round radii is R6 unless noted, or you just simply put all fillets and rounds R6. Size dimensions for cylinders. In the upper left there, you have a diameter dimension. You basically have two diameter dimensions. Okay. And then the lower drawing in the middle there, you got a sort of a weird, it's eccentric for a canning machine. That's pretty confusing on how they put those dimensions in there, but that's usually what happens right there. That's an actual drawing. And upper right is a section drawing with all the dimensions attached to it. Remember, start small, go out big. Size, dimension, and holes. The leader of a note should point to the circular view of the hole if possible. Okay, so you notice in that upper left, all the holes are dimensioned, not in the right side view where all the hidden lines are. Remember, you want to see the hole, put a dimension on it. And to the right there, you got a hole. The arrowheads, if you look at the arrowheads and the leader line, they're pointing directly to the center of the circle, both of them, unlike the one on the right where it's not, and that's a bad thing. I would mark points off if I saw that. Going down below, you have on the left you have a drawing of a countersink. You have a top view and a front section view, and that's a countersink drawing. And in the middle there is a threaded drawing. So on the top view is how the threads are drawn and labeled, and then the section view down below it just shows you how they would actually draw the threads if they were going to do that. And on the right hand side you have a spot face. Okay, a hole with a spot face in it. Spot face in the counterbore is similar, except spot face is just real shallow, not very deep. Okay, We'll take another break again. Bye.